Hello, welcome to my talk on FOSDEM 22 MySQL Dev Room. So today we're going to see how we can do logical backup, snapshot, and point-in-time recovery with MySQL 8 like a Rockstar. So let's start by some presentation. So my name is Frédéric Descamps. I am a MySQL evangelist in Oracle. You can follow me on Twitter at Lefret. I'm hacking MySQL since a lot of time. So my first version was 3.21. I'm living in Belgium here and have a website where you can find a lot of information related to MySQL. So in 2022, there are some best practices when you are using MySQL, and I'm going to cover them right now. So first is that you need to run MySQL 8.027 or later. MySQL 8.028 just came out this week. Use only InnoDB. Has binary lock enabled. It is required for doing point-in-time recovery. And the binary logs must, of course, use the raw format. Don't use statement-based or mixed-based replication anymore. And, of course, enable GTID. So what is point-in-time recovery? It's, of course, using the binary logs. So point-in-time recovery, it's a technique whereby an administrator can restore or recover a set of data at a certain point, usually in the past, point in time, right? So in MySQL, point-in-time recovery consists in restoring a dump of the data and then replay the binary log from a specific point or to the end and bypassing some information. So this technique, it's used to fixing a problem. So this is where we bypass some transaction, or when we do a live migration, and I will talk about that in a moment. So how does point-in-time recovery works in MySQL? So this is what we have. We can see here we have time, so we have 4 days, and we make dump every day, so a backup here in this case every day, and you can see at the on the bottom the binary logs. So how does it work? If we want to recover at this point, so the point here marked between day 3 and day 4, what do we need to do? So the first thing we need to do, we need to restore the dump of day 3, so the last backup before the point we want to recover. So this is what we do. So we restore that dump on a database system, and then we replay the binary log 008, which is the binary log since day 3 up to the point we want to recover. But usually after a backup is made and verified, this is very important to verify your backup, binary logs files are purged from the MySQL server. You cannot keep binary logs forever, right, on your database production, for example. So what happens? This is what we have. Every day when we do a backup and or a dump, we can see that when we verify that backup, the binary logs are purged. So meaning when we have this situation right now, what can we do? The recoverable point in time are day 1, day 2, day 3, day 4, just the time when the dump was made or the backup was made, and any time after the last one and while we have the binary logs. Right? So this is a very important concept to understand. So as you can see, we can only recover to the exact time of the backup dump and do point-in-time recovery only from the last one where we have the binary logs. And this is why we recommend to also stream the binary logs somewhere else, another server, a NAS, the cloud, wherever you want, but to also save these binary logs. This will allow to make point-in-time recovery at any point back in time. Of course, this depends on what are your requirements. You can maybe save them for 3 months, a year. That I have no idea. It all depends what you give as a DBA to the users. So here you can see we do the dumps, we save them somewhere, and at the same time we stream all the binary logs on somewhere else, not on the MySQL server, and we keep them. This gives us the possibility to do this, to recover any time from the first backup to the end of the binary logs. Okay, the binary logs we have. So point-in-time recovery for fixing something. What should we perform point-in-time recovery? So if a user made a mistake, we need to find back data to a certain point in time. So if somebody says, oh, 1 week ago at noon, I saw some information, but that information is not there anymore. What was it? How was it at that time? So we can go back in time to find that information. And we need to have an overview of the database at a certain time. Same stuff. This is for fixing an issue. Now, when we need point in time for live migration, it's when we do large migration to the cloud, for example, the load time of the data can take longer than the binary log retention we have on the system. So the MySQL Server production you have on premise or in another cloud that you want to migrate from, that MySQL Server should be used as the replication source. But if the binary logs are not there since the dump, it will fail. So you need to do point-in-time recovery up to the time of the binary logs you have on the production system, right? So here on day one, we have the dump, right? Usually a logical dump when we go to the cloud, and we start the load to the cloud instance. Meanwhile, we stream the binary logs to a safe place. Then you can see here at day 4, so it took 4 days to load all that data to the cloud. We can see that when it's over, the data set was in GTID 003. But on the source, on premise, we can see that we don't have that information anymore, because now the binary log here, we can see the binary log is 0010. 003 was purged, right? So here we are 0010. So what do we need to do before being able to start replication? Because if we start replication here, it will fail. It will say, oh, the next transaction, next GTID, it has been purged from the source and it won't work. So what we need to do is we need to replay all the binary logs from 003 up to the point we are now. In this case, it's 010, but of course, it can be even more, right? Because the production is still running on the on-premise server. When we recover everything, we can start replication and it will work. And then we are ready to do a live migration, right? So now let's talk a bit about backups. So backups, physical, logical, snapshot, all that terms are what usually you encounter in the documentation, or when people talk in Slack or wherever in the forums. Everybody says backups, but what does that mean really, right? So for years, physical hot backups were recommended, and I recommended that a lot of time for a lot of systems. But with the increase of the use of cloud for MySQL, logical backups are coming back to the forefront, because physical backups are not always possible in the cloud, right? So first with MySQL dump, but as you may know, this tool, it's not optimal in the MySQL dump. It's an old tool, which is single-threaded for dump and also single-threaded to load the data. So we should avoid to use MySQL dump. And this is why we in MySQL came up with the MySQL Shell dump and load utility. So this is what you need if you want to migrate to the cloud. This is the tool you need to use. If you don't care about the cloud, but you need to do a logical dumps, this is also what you need. So MySQL dump shell and load utility was introduced with MySQL 8.021. It supports export of all or selected schema. So just specify schema or all of them, the full instance. It supports local storage, could be that local storage can be a mount to S3, for example, and OCI object storage natively. So no need to mount it on your system. You can directly store the data to OCI object storage. It supports dump from 5.6 since 8.026, 5.7, and 8, right? It can fix your schema. So it can force InnoDB. So you can dump some data that was, for example, not InnoDB and said it has to be InnoDB. For example, you don't have primary keys. You can say, oh, add an invisible primary key. right? So this is very good when you load the data. And for example, primary key, you know, it's very recommended in InnoDB and must have when you do use HA and replication. You can dump and load all in parallel. And it's not here, but you can also start the dump and start the load at the same time, and much more information. So I recommend you to go and check on the manual about dump and load utility. So to illustrate this, what we're going to do now with all what I'm saying, we're going to use for this presentation the following system. So I'm using an Ampere compute instance. So it's an always free instance in OCI. And so it's ARM machine which has 4 CPU and 24 GB of RAM. I will use MySQL Server 8.0.27 and MySQL Shell 8.0.27. So because I made this just before 8.0 came out. So, but now you have 8.0.28 out. So please use 8.0.28. I'm also using sysbench 1.0.20 to generate some load and data, and a specified table to play with that I will call FOSDEM T1. Okay. So sysbench, so this is sysbench, it's running, as you can see, it does OLTP read and write. And after I will also use OLTP insert only to generate even more binary logs. And it starts in the background. I use that screen in my shell, so meaning that I can detach it and let it run forever. And my FOSDEM T1 table is very easy. It has an ID. It has a varchar for name. It was the timestamp when it has been inserted and the timestamp when it has been updated. And the primary key, it's the ID. So nothing very complicated here. You can see we have 5 rows. I'm using this just because it's much easier to find information in such an easy table than in the data generated by sysbench, which is complicated to find the information in it. So we do the logical dump. As we planned, we use our logical dump as a backup, and or at least for initial dump. And we won't focus on specific schema. We dump the full instance we have. So we're going to use util dump instance. So this is how we do it. So we run MySQL Shell, where we connect. As you can see, here we are on the local machine. We use util dump instance and a name and a folder where it will be output. And I use the data generated from Bash. Very easy to do that. And this is how it looks like. So it starts. By default, it uses 4 threads in parallel. As I'm using a machine with 4 OCPU, I don't need more, so I let it to the default, but you can configure that if you have a machine with much more CPU power. And if you plan to migrate large machine to the cloud, I always advise to use a compute instance with a lot of power to do that, to make it very fast, right? So this is, you can see how it works. It compresses the data automatically. It generates everything it needs. And we have also some information that is very important, which is the metadata. And the metadata of the dump, it's in a file called at.json in the directory where we made the dump, right? The target directory. So for example, if I check this file, as you can see, it was backup. I did that the 11th of January at.json. And we can see here we have the GTID executed with which was the GTID of the data set we have. And it also tells us that the dump is consistent, right? So this is what we need to be able to restore a consistent dump. Then we can see that our dump, yeah, like I said, it's consistent. This is the GTID we needed. And on the MySQL server, we can see that sysbench, of course, in the background is still running and keeps generating data because the GTID executed, it's higher than what we had here. You can see here, it's higher than this one. So now, snapshot, physical hot dumps. So there are multiple ways of doing snapshot. We can do hot backups, so using map, extra backup, and these have plenty of features. And it can do full backups or partial backups, incremental backups, and it can be very complicated to operate. And of course, it also not supported in every cloud platform where you don't have access to physically to the server. File system snapshot, they are not always hot because it depends also of the technique you are using and the file system you are using. So maybe sometime you need to freeze everything to be able to do that, that snapshot and then continue. Or we can use something called MySQL clone. And this is where I want to put my focus, and the highlight, it's clone. So clone was introduced in MySQL 8.0 It permits cloning of the data locally or from a remote MySQL server instance. And the clone data, it's a physical snapshot of the data stored in InnoDB that includes schema, table space, and all the data dictionary metadata we need. Of course, clone, it's only compatible when you are using InnoDB. So you should not have other type of storage engine. And of course, this creates a fully functional data directory. This is the output of it. And this is what we use the same technique to provision a server when we do, for example, InnoDB cluster or replica set. So how does it work? So in SQL, because this is a SQL command, we just do clone because I want to clone it locally because I have only one machine now. I do clone local data directory I give and where I want to put that data, snapshot. And that's it. As simple as that. So clone, it's very fast, it's in parallel, it works very well. I know a lot of company who has moved to this technique, and this is a very recommended technique if you need a full consistent snapshot. Because we didn't stop MySQL, we have still access to the server. We can see that in the performance schema, there is a table, clone status, that provides us the GTID executed when we did this dump using clone, right? Now let's have a look at binary logs. So all the data change are stored in the binary logs. So the MySQL workload for writes are written in the binary logs, and we can have information. We can do show binary logs, and we can see all the binary logs we have. And as you can see, if you have access to the file system, which you may not have in the cloud, we can see that they are on the file system in the data dir, for example, here, and we see all the binary logs. By default, the size of a binary log, it's 1 GB. For this example, I will reduce to create more binary logs. So I will reduce the size by 10 using set persist max binlog size. So keeping the binlog safe. So as you may know or not, the MySQL binlog has the possibility of reading the binary logs from a remote server and store them on the disk using the option raw read from remote server. So we're going to create a script to use the MySQL dump to do that, to connect to our server and stream the data locally. And we're going to use systemd to start and stop our script to make it much easier. So if you are interested by that script, these are the source on GitHub. You can have them and play with them, right? There is, of course, I don't provide you support for the script, but if you find some issues or whatever with it, I'm always happy to hear from you. So now we need to create a dedicated user for the streaming process. I always recommend that every application has their own user, to not use root every time, and so on. So we're going to create a user. I will call it binlog streamer. I will identify it by his own password. I will require SSL to encrypt the communication. I will grant replication slave on for that user on every table. And also I will allow the user to read performance schema file instance. This is for a script I use to find what is the last binlog we need to restore to start streaming from in case of there was a network issue or the process has been restarted. So, and to avoid to store the credential in the script itself, we're going to use the MySQL config editor. MySQL config editor works very well, but you've seen that this is a tool that is not that popular. So I try to make it more popular by always propose to use it. So this is how it works. So we're going to use MySQL config editor set. We're going to create a logging path. I call it localhost, host name. So this is my local machine. the user, binlog streamer, and the password, and we enter the password we just created. So we don't have in clear text the password somewhere. Now, because we are, I created that systemd system, I will copy it on the system. I reload the daemon, and then I can start it, right? Binlog streamer at localhost, because I created the script the way you can have multiple stream from the same machine. So the same machine, the compute instance, could stream and save data from multiple other servers. And then we can see the system and where it streams the data, right? Nothing complicated so far, but at least we are streaming the data live, and we can see it. If we go where we save the data, we can see here that we are streaming live all the data coming from our production server. So this is very, very important. And now let's make point-in-time recovery like a Rockstar almost, with some example. First, normally. So let's have a look here. So I am on the system, and I will change the name of one of the user in my T1 table, and I do update T1 set name equal demo. Oops, I forgot the where clause, right? So after the application was still, I didn't notice that directly, me or the user doing it. And then I keep inserting data. And in this case, I will insert another record, which is left. So if I check what's going on here, what we can see is that we have lost all the names, the previous name of the users. We don't know what they were, and we don't know what happened else in the system, right? So, and all the sysbench information also was still running. So it means I cannot restore the backup. I lose all the data that sysbench created, and I will also lose the data, for example, in this case, the insert le thread in my table, right? So thank you, Demo. So what's the action plan to recover that data? So the first thing to do is we need to restore the last dump. Then we need to set the GTID purge to the GTID executed of the dump itself. Then we need to find the GTID of the transaction we want to bypass. So that update without the where clause, we need to find it to bypass it. And finally, append the GTID to the GTID purge, right? So that GTID we will append to the GTID purge. So we will bypass it when we're gonna replay the binary logs. So then there is one question we need to answer. It's, do we use another instance? So we can use another instance and then just bypass that binary log, restore the dump, and start a replication, and that's it. Or we use the same machine because we don't have any other machine. So and in that case, we need to replay the binary logs manually, and this is what we're going to do, right? So I choose to perform the point-in-time recovery on the same machine to show you how we can accelerate the process if this is the only option we have, meaning having only one single machine. So before we start, we need to have some action point that we need to do. And if we plan to do point-in-time recovery on the same instance, you need to stop the application, of course. So in sysbench, in our case, we need to stop it. Then we need to check the last GTID executed. This is not necessary, but at least we have an ID up to where we need to go. And also not needed, but for us to show it works, we're going to do a select count on the sysbench table because I was inserting a lot of data to have an estimation if we were able to restore that much of data or not. Of course, we need to stop the binlog streaming process because it is not needed at this point. So we check that. So we do the select GTID purge. We have the information here. We can see we have a very large number with more than 5.8 million transaction. And then we check on T1 and we have the information about all these tables in T1. So, and we stop the streaming because it's not needed. So the first thing we do, we're going to restore the last dump we have. So we have, again, several options, and I will show you both. First, restore the logical dump we made with the MySQL Shell, or restore the snapshot made with clone. So let's start first with the MySQL Shell utility. So to restore a dump with the MySQL Shell utility, we need a server running. So we need to remove all non-system schema. So I will drop the schema FOSDEM, I will drop the schema SBTest, and then I will load the data. So I will load all my dump. I want to show the metadata. Here you can see here I have show metadata. And I don't write that in the binary logs because it's not needed. And we have that information. You can see that it provides us the GTID executed of the metadata. And it does that. You can see that it does all this load in parallel for the 9 tables it has in 2 schema in 7 seconds. And we can already check what the table looks like after the dump. So we can see here, we have the table like it was at the dump backup, right? Now, we still need to set back the GTID. So if we check the GTID purge and the GTID executed, because we haven't done anything, the system still has the GTID executed. It has up to when we stop the application. Then we need to reset master to remove all that GTID information. And then we're going to set the GTID purge of the dump we did. So we had in the metadata, so we add it here. And now we can see that the information has purged all the binary logs up to that point. And this is where the data set looks like now. Then we're going to start the restore of the binary logs doing what we call the point in time. But first, we're going to also see the same restore using clone, right? So as the plan is to restore the snapshot on the same server, we need first to save 2 important files in the MySQL data directory, AutoCNF, because it contains the server UID and we want to keep it the same, and MySQLD AutoCNF containing all the configuration change done using setPersist. So this one, we want to keep them. And if you have some dedicated keys in the data there, you should also save them to not recreate new ones. So we do that. So we copy that information. We put that in the snapshot directory. And then we now stop MySQL and we empty the data there. We copy back the snapshot to MySQL. So we copy back all the files we have in snapshot and we put that in the MySQL data there. Then we change the ownership of the files to belongs to MySQL, and we can start MySQL. And we can see that all the GTID are already in place. This is the GTID set of the restored data. It's automatically using clone. As you can see, clone is very easy also to do that. And so now we have restored the data using dump or using clone, and the dump utility from the shell, I mean. And now what we need to do is to find the GTID to bypass. So we need to find a transaction where we did something wrong. So where we modify all the user as being demo, because if we replay all the binary logs, we will replay also that transaction and will be at the same point as we went when we stopped MySQL, meaning that all the data we wanted has been gone by this wrong transaction. So we're going to use the binlog command, -v, -b64 output decoding rows, and the binlog files we're using grep to find where it comes from. And we find that this comes in the MySQL compute binlog 000029. So we can check it here, grep FOSDEM, because it's the only one I type in FOSDEM, and we can see we did update, demo, nowhere, close, nothing. This is exactly what we did wrong. So we found it. And we also found the GTID we need to bypass. You can see it here. This is the GTID we need to bypass, right? So now we're going to also purge that GTID. We're going to tell to MySQL, okay, please add this GTID to the GTID purge. And this is very interesting because not everybody knows. I think so when I see some question. I use this plus. So I don't need to put all the GTID purge and this one included. I will just do plus here, set global GTID purge plus and the GTID I want. And this one has been append to the GTID purge, right? And executed. And then we could replay the binary logs one by one to our MySQL server, but that can lead to a very long operation using MySQL binlog because it's single-threaded. So unfortunately, on a cloud managed instance, this is the only feasible method to replay the binary logs, and repeat that for all the binary logs. But we are not using a cloud instance here, so we can do it like a Rockstar. So we will let believe to MySQL that those binary logs, stream binary logs that we're gonna use are in fact relay logs. And so the applier threads the workers here will be able to do it in parallel, right? So let's have a look. We find the name of the relay log on our system, and it's called mycomputerelay.bin. Then we're going to copy all that information, all the relay bin we have, and we're going to replace, we're going to copy them on the data dir, or where the binary logs are usually, and we're going to rename them as relay bin, the name we got before. After that, we need also, of course, to change the ownership of these files and create the index, also the index file. So this is what we do here with the ls, and I put the output in here in the index file, right? And I change the ownership of to be MySQL for that file too. Then we can verify that we can ingest relay logs in parallel. We can see that we have a logical clock, replica parallel workers are 4. This is enough for my system because I have only 4 CPU, but if you have more, don't hesitate to add that, right? And if you can restart MySQL, it's always good to put log replica updates to 0 to not generate again binary logs for this. We start the process of doing the point-in-time recovery. So we need to change the server ID to something we don't have for the current server right now. So we're going to put 99 in my case. Then we're going to change the binlog transaction dependency tracking to write set. Write set meaning that the dependency information is generated from the source write set, and any transaction that write different tuples can be parallelized. So we have commit order, write set, and write set session. So I will put it write set here. And then we're going to change replication source to relay log file, and I use the relay log here, put 002. It's better to put the relay log to when we did the snapshot, because we need to process them to see if they have some information we need or not, but it's usually fast enough. But in case of, you can put here the log file of the latest dump with it. Then we put relog post 4, and the source host I put dummy, and I don't start replication, I just start the SQL thread. So this will generate, ingest all the relay log very fast in parallel. You can verify the progress of all this in performance schema, in replication applier status by coordinator and replication applier status by worker. You can see here all the workers, what they are doing. When it's done, we can verify here, right? All the GDAD executed, we do the select, and we can see that it's exactly the same amount. And if we want to check in our table, so FOSDEM T1, we can see that the transaction we did after that one are there. So you can see here, the thread it's here. But the one we bypassed that was modifying all these as demo, is gone. So this is perfectly what we wanted to do, because we were able to bypass the wrong transaction. So of course, don't forget to put back the value of the server ID before you start again your application. So, and in the cloud, if you want to do that, the same technique in OCI, for example, with using MySQL database service this time, so not a compute instance. So this is what you do, right? You will have your MySQL database service. You can stream the binary logs using a compute instance that will save the binary logs to object storage, and you can use MySQL Shell to do the dump and load. But this is not mandatory to do the logical dump and load, because as you know, the backup and the snapshot are managed already by the MySQL team. So you already have consistent snapshots every day. The binary log are purged every hour by default in MDS. So this is why I recommend that you need to stream these binary logs on object storage, for example, from a dedicated compute instance that will be used for that. Okay. So if you are interested in doing this with object storage in MDS, I already wrote some articles on that. So I point them to you here. So this is the end of my presentation. So thank you. Now, if we have questions, we can go live and discuss this all together. Thank you very much for following.